Hello everyone! Today I'm gonna talk about one of my favorite theories in all of physics. So basically everyone knows how the universe started. With the Big Bang was an infinitesimal point, and then it basically exploded and expanded and until what we have today. Well, according to eternal inflation theory, that is the truth, but not all of the truth. So this is gonna be easier if I explain it graphically. So I present to you the inflaton field. This is a quantum field, part of eternal inflation theory, and it basically controls inflation, which is basically exponential expansion. So let's say this is the energy axis, and this is a really popular way of representing it because it can really give a sense of how stable the field is. So when the universe started, all the quantum fields were at their default states per se, and the inflaton field was at its highest point. And the more energy there is, the more inflation, the more exponential the expansion. So with a value this high, the universe started expanding exponentially, and as it expanded, the energy density of the rest of the fields, say this for example, also went down. So the fields went down in energy, and the inflation field also went down. But instead of going in this direction, it went in this one, and it ended up here. This is what we call a metastable state, because it's stable but not completely, because it could get less energy, so more stability. So as you can see, it still has quite some energy, and so the universe continued expanding exponentially, although not so much now, but it continued. And so the other fields also continued lowering their energy. And the inflaton field also wanted to lower its energy and become more stable, just like its cousin fields. But it couldn't because it was sort of trapped in this metastable state. So the universe continued expanding exponentially, and the other fields continued lowering their energy and becoming more stable, but the inflaton field was trapped there. And it reached a point where the sheer impulse to lower its energy and become more stable became so much that it just went all the way down here from there. And so exponential expansion or inflation stopped. And quite a few things happened then. So let's say this is the universe right now, and this is the energy of the inflaton field. So when it finally lowered its energy, where did all those inflatons go? Well, they transformed into particles and heat. Does that remind you of something? Yeah, the Big Bang. Okay, so the interesting part comes here, because due to the random nature of quantum fields, this lowering of energy didn't happen all at once, but at random spots, at random times, in this higher universe, let's say. So these things were, well, matter, and they expanded now not exponentially anymore, but, well, normally, at a constant rate, basically. And each of these is a Big Bang. So they're basically like bubble universes. And so these bubble universes kept expanding, but the greater universe expanded at an exponential rate. So the spaces between them also increased. And so more universes could be spawned in the space between them, and then would expand, and more universes are created every time. Now, let's talk about the implications of this, because they're crazy. So, as you might have noticed, when the bigger universes get pulled apart due to the exponential expansion, of the higher universe. Okay, we need to put an official name to that, but more tiny universes get formed and expand, and more tiny universes form between them. That means that by nature we must be one of the first ones to, well, exist, because there are exponentially more universes after us than before us. And there are also some things that I've thought about, but that I haven't really been able to verify. For example, if the different universes have different laws of physics, then that would basically explain why we are here. Like, if there's a random variation between laws of physics in each universe, there must be at least one, ours, and probably many of them, in which the conditions match exactly those needed for life to inhabit that universe. Also, if you think about it, when the inflaton field went from a non-stable state to a metastable state, some bubble universes with a slight amount of matter should also have been generated, so then there should be two types of universes. Our universe, well, we really wouldn't know, but the universe with more matter, with the entire inflation field worth of matter, and universes with some matter and some energy, when the universe lowered its energy into the metastable state. And finally, and probably the coolest implication of all of them, if two universes get generated really, really close to each other, the exponential expansion of the higher universe isn't able to pull them apart, and instead they collide. And actually, we thought that this had happened with our universe because we saw a really big cold spot in the cosmic microwave background, although it ended up being just random chance. So thanks for watching. I hope you enjoyed the video as much as me, and if you did, please like and subscribe. And as you might have noticed, I've got a new t-shirt with my logo on it. It's not merch, it's from my parents, and also my username is wrong. It has a YT in capital letters after that, because someone took my name before me. Can you believe it? Anyway, shout out to my parents, thanks for the t-shirt, and I'll see you in the next video. Bye! Colliding universes. Could you believe it? Whoa! No?